Hello and welcome to episode 5 of my video series on building a model railroad to a Northern Netherlands prototype. In a previous episode I mentioned we were going to look into wiring. That's partly true. Small little lie told. I'm also going to show a little bit about installing a turnout on the layout and the last little bit of baseboard construction of the storage yard behind Rodeschool, which I've named Warffum on the track plan that I introduced in the previous video. Having said that, there will be a bit of wiring at the end, and that's mainly to do with how I wire up point motors. And point motors I tend to use are those by Circuitron, the Tortoise point motors. I've had several of them on my previous layout, so I'm reusing them. They're in good shape. They are built like a tank, so for that matter, that's why I've decided to do so. So without further ado, let's get into it. So let's have a look. We're doing the last bit of baseboard construction here. As I mentioned before, I'm using MDF risers here that I'm screwing onto the support beams, which, as you can see, I've attached to the roof, so that helps saving a little bit of woodwork, and it's quite sturdy. So yeah, the last risers go in. Obviously make sure they're level, not to be underestimated, because you don't want any wagons or coaches to go all over the place. So the top is made of 12mm plywood, and nice and sturdy. In the past I've used thinner wood material, but honestly invest a little bit more in the good quality wood, and you would it won't be so flexible. It won't be affected by the weather too much. It's actually quite important to do that right. I've always skimped on that in the past, and with regret. So we're doing it right this time round. So let's have a look how we wire up a turnout or point, whichever way you want to call them. This is a PECO 75 turnout, medium size. That's the type I'll be using mostly on the layout, and it's the Electrofrog variety. So what does that mean? That means that the frog, or the point element here, can conduct electricity. That means that particularly locomotives with short wheelbases and limited power pickup won't stall if this was to be molded out of plastic, as is in the case of other types of turnouts that you can find around in the shop. So, but as you can see also, the two rails meet each other in the middle, so you could also have a short circuit on that spot if you don't wire the layout up correctly. And to prevent it, these two pieces of track will have to be fitted with an insulated rail joiner, which isolates this section here, from the rest of the layout. So you need to power it, obviously, and that's what this little wire is for. That is being fed power depending on which way the point is thrown, either this way or that way. Let's try that again. Yeah, either this way or that way. And an auxiliary contact in a turnout motor ensures that the polarity of the frog is being switched from one to the other stock rail, and that makes sense. So it'll be the rail on this side if the point is in the diverging position, and it'll be this side if it's in the straight position. So let's have a look how we do it. Firstly, we're also going to make the contact of this section of turnout here and here a little bit more robust. we don't want to rely on power on these two plugs by contacts of the actual turnout blades themselves. There's a little bit of dirt here, or it's not fully thrown. You could end up with no power on these pieces of rail, and that's obviously another problem that you could find. So what do? We're going to make electrical connections between this rail and this rail, and this rail and this rail on the underside of the turnout. And PECO has actually thought of this. To do that, there are already areas here and here where the webbing of all the ties is interrupted, so you can actually put jumper wires in that position. So that's what we're going to do now. It'll always help to tin the bottom of the track in this position beforehand. That makes the solder flow much better, and also prevents you from melting the adjacent ties. We don't want to do that. So first I'm going to tin them up. So I've added some flux just now with a brush to ensure the tin that I've got here, the solder, is going to flow properly. So there we go. This one. From here it's still probably 2, 3, and 4. Lovely. So that's the bottom of the turnout tinned. Have a look at the top. No solder has flown to the top of the rail, so you've got to be careful that you don't overdo it, because you don't want a blob of tin on the inside of the rail here, because that's going to cause you derailments and everything else. So next is to attach the 2 wires. But firstly, also then I'll tin them so they will connect much easier when we're ready. So here they are, a red and a black one, which is the most common color coding for track power, red and black. There we go. Just also here we'll thin the wires. Get the solder flow, that's one. That's 2. It's long enough. Just have to make sure that I connect the wires to the right ones. Put this out of the way. So I know that the layout turnout will be on the layout like this, and this will be at the front, so that is red in my case, because I use, like many people, black to the back, which is a nice way of remembering it. Black to the back. One can't go wrong. So let's solder that one up. I've tinned the wire, I've tinned the track, so just a matter of introducing a little bit of heat. And there we go. That's one. I have a slight blob here, but nothing to be concerned about. And let's do the other side. One and 2. Let's just double check if that is all connecting properly. Yep, it is. So here we go. That's the result at the bottom. And again at the top, no solder is touching the track anywhere. so as in not on the top, so all good. So finally we need to wire up the frog itself. There is already a piece of metal wire connected at the bottom of factory, but obviously it's not long enough, so we're gonna have to extend it a little bit. And also here I'm going to be using a little bit of solder in advance and tin the frog wire for a moment. There we go. Now you wonder, why green? Well, for me, you know, it doesn't really matter what color wire you use on your layout as long as you're consistent, but I've always thought green is a good color for a frog, because frogs are green in nature, so it's a good way to remember it. So that's your second little mental trick. So black to the back and green for frogs. Solder that one up too. Oops. Maybe use a little bit of flux again to prevent having to introduce too much heat. Let's do that again. So that's much better. And now we can connect green wire, and look at that. Done. Using a good soldering iron obviously helps as well. You can get decent ones for 20-30 pounds. I'm using a soldering station, but you don't have to go to that expense. But if you can set a temperature, I would recommend that for most standard solders you set the temperature to about 360 degrees centigrade if it has a thermostat. That is a value that's also used in industrial applications and military applications, and they tend to give you good strong solders. So that's that. All that remains now is to fit it into the layout. Well, actually not quite. We also need to cut through these two jumpers here a little bit further along. Otherwise, because of the other jumpers that we soldered on, we're going to create short circuits when the throw bar is thrown. So there's two little jumpers on the bottom of an Electrofrog point that you need to cut away, and that will solve your problems. So let's repair the Tortoise turnout motor. The throw bar has a little diagram on its manual to bend in shape prior to you fitting it to the baseboard. I would recommend prepare that while you got the Tortoise off and not fitted, because it's a lot easier to do with it disconnected. So just follow the diagram on the manual that you can see there, and bend it to roughly to the right shape. Slightly off is not a big deal. You can always adjust it a little bit, but you know, try to get it as close to. See, I'm nearly there here. Slight adjustment, and then should be okay. So fitting them, we take the motor. Here we are. It's got a little bracket that slides in from that way, and depending on how high you install it, you can slide it up and down. You can adjust the width of the throw bar. So you know, if you were to use it with an N scale turnout, you possibly didn't need the same distance as you do with an HO1 or a OO. But also it also depends on the thickness of your baseboard. So experiment a little bit with the correct height for the turnout that you're using, and you should get the throw in the correct position. Just try it for a moment, and here we go, all good. So I've placed the layout, the turnout in position. Obviously the wires are laying on top here, and the first thing to do now is to mark off the holes where the wires have to go, the dropper wires have to go through the surface of the layout. over here, as this is the storage yard, I don't have to be too worried of having visible wires on the top of the baseboard. Obviously I'd be drilling holes much closer to the actual track if I'm working on visible parts of the layout, but in here it isn't so complicated, and I'll make it myself easy. Now the other thing I need to do is to mark the center hole of where the rod of the turnout motor will come through, and so I'm just marking off 2 centers, one here and one there, and the same on the throw bar, there and there. And let me just point out the way. There we go. I'll just put that out the way for a moment. So I have that. Just use a little bit of tool to go 1 and 2. So that'll be the center hole for the throw bar. So I have the drill nearby. So first the 2 power holes. Oops. Make it turn the right way around and a bit quicker. Get the drill after all. Same here for the frog wire. And I'll drill a pilot hole for the bar. Okay, that's that. Lastly, here is my template for my turnout motors, and that will help me to fit the motor in the right position. So let's go ahead and drill the holes, mark them off with the template as I mentioned. And we'll drill the holes. First, the small drill the pilot holes for the fitting of the motor, and then a small hole through which the throw bar has to go, and then we'll enlarge it to the right size, get a bigger drill on there, and here we go. Depending on how thick your baseboard is, you may use bigger or smaller drills, but that's easily found out by experimentation. So we've put the turnout back on the baseboard, connected it up with the rail joiners, and so here we can see the turnout motor on the bottom, with the throw bar through. So all that remains is now to feed the wires through the baseboard underneath the layout, and prepare them to connect them to the contacts that are on the turnout motor. So I'll show you that in a minute, because as I mentioned earlier, there are contacts on the Tortoise motors, and there are 2, as a matter of fact, for 2 functions you could do. So let's have a look. So here's the Tortoise motor again, as a printed circuit board, and you can actually slide on a connector onto them. And here's a diagram in the book, and as you can see, it's got 2 single pole double throw contacts in them, connected to 2, 3 and 4, and 5, 6 and 7 respectively, with contacts 1 and 8 being the contacts for the motor. Now the motor is a DC motor, so if you change polarity from number 1 on 8 and swap them around, the motor will run the other way. So the contact is obviously used for frog polarity on the one hand, and you could use the second contact for all kinds of feedback. In my case, I'm going to be using that for my position feedback of towards the decoder, because the storage yard being hidden, I'd like to have security of knowing which way the point is thrown, particularly when I can't see them. So these are the decoders I'm using, Lens LS100s with 4 outputs. So here's the contact block, which I'm first going to have to thin. Solder them up a little bit. I've started here with the frog polarity ones, and you may have seen me wave around a tester just now, and that's obviously to test which contacts are made when the switch is in a certain position. So measure it first, bleep them through with a little tester before you solder your wires on. And here again, here's the frog wire, green for the frogs, and then we'll go on with attaching the reds and the blacks, which are the two colors I'm using for my two tracks, as you know, and again black to the back. So solder them to the respective contacts of the connector that you can get for the Tortoise. You could also connect them directly to the circuit board on and hardwire them, but I find using a connector like this a far more elegant solution. So I'd go with that.
So I've gone ahead and wired all the wires up. What I've done in my case is, as I mentioned, red and black are the two track buses, green is the frog, and then for polarity position feedback to the DCC system itself, I've used grey as a common wire, blue for the feedback when a point is in its straight on position, so straight position, and white feedback for the diverging track. So no matter whether it's going to be a point that's turning left, it's left-handed or right-handed, it'll always be those color codes that I will follow. So in some cases for other points that are right-handed points, I would have to swap the blue and the white color out here. Now for the motor, which is a DC motor, I have decided to use purple as one of the feeders and brown for the other one. So brown and black are at the back and purple and blue are at the front if the point motor is in this orientation. I will endeavor to mount all of the tortoises in that orientation unless there is a frame, girder or whatever in the way that doesn't allow me and I have to turn it around, but obviously I need to make sure that I keep my color coding accordingly. So always test before you make your final fitting.
So I hope you're still with me. That was a long video. I apologize for that. I tried to make them a bit shorter, but this was such a important topic I thought to share. There's not enough of this sort of information out there, in my opinion. So I hope I've done it clear enough for you to see how I do it, and hope that you got some out of it. One final word, I mentioned color coding there a while, and you see me at the end there using various different colors. What colors you choose for your layout is totally up to you, but just write them down and make it a plan so you stick to that schedule throughout the entire build. Don't think when you have a bit of leftover yellow wire, but it should actually be orange, and then stick that on. It's gonna cause you problems in the future if you have to troubleshoot. Best just make the investment and buy a little bit extra wire of the correct color. You'll be thanking me later. Anyway, so much for episode 5. Hope you've enjoyed it despite the length. I'll try and make them shorten, as I said, going forward. So if you liked it and you want to see more of this, please like and subscribe so you won't miss the following one. And if you want to be really kind, buy me a coffee. The link is in the description, and I'll see you in the next video. See you soon.